Even though space may seem like a billionaire's playground more than anything else, real, significant improvements in rocket tech are happening all the time. SpaceX, for example, is already launching and landing its giant Starship prototypes. Now, they get a look at Relativity Space, a private aerospace company building orbital rockets using 3D printers. If you would like to learn more about 3D printing, then take a look at this video. Hello, and welcome to another exciting video from our channel. In today's video, we will tell you everything we know about 3D printing. But before we start this topic into the details, do not forget to like this video, subscribe to our channel, and hit the bell icon to stay up to date on our latest videos. Today, 3D printing technology using heat-resistant metal alloys is revolutionizing trial-and-error rocket development. Whole structures that would have previously required hundreds of distinct components can now be printed in a matter of days. This means you can expect to see many more rockets blowing into tiny pieces in the coming years. But the parts they're actually made of are set to become larger and fewer as the private sector space race intensifies. Rocket engines generate the energy equivalent of detonating a ton of TNT every second, directing that energy into an exhaust that reaches temperatures well over 3,000 degrees Celsius. Those engines that manage this without rapidly disassembling in an unscheduled fashion take at least 3 years to engineer from scratch, most of which is taken up by the cyclical process of redesign, rebuild, refire, and repeat. That's because rocket engines are incredibly complex. The Saturn V's F-1 engines that blasted Neil Armstrong towards the moon in 1969 each had 5,600 manufactured parts. Many of them were sourced from different suppliers and had to be individually welded or bolted together by hand, which took time. A redesign of the Apollo F-1 engines using 3D printing reduced the number of parts from 5,600 to just 40. No company has yet to reduce this number down to 1, but it's undeniable that 3D printing has brought about a new age of fast, responsive rocket engine development. This lengthy, expensive process might have been fine in the 1960s, with the US government funneling money into NASA to fuel the space race. But for private companies, it simply takes too long. The key to fast engine development is to reduce the number of parts, which reduces the time it takes to assemble the engine and the disruption caused by supply chain delays. The easiest way to do this is to change the manufacturing processes. Space companies are now moving away from subtractive manufacturing processes, which remove material to shape the part, to additive manufacturing processes that build up a part by adding material to it bit by bit. 3D printing is actually an entirely new tech stack for aerospace that we really haven't changed the paradigm of in the last 60 years. Building products one at a time by hand with hundreds of thousands to millions of individual pieces, parts in a factory full of fixed tooling and a very complicated supply chain, Ellis said. 3D printing. Increasingly, engineers are favoring a process called selective laser sintering to 3D print rocket engines in an additive process. It works by first laying down a layer of metal powder before melting shapes into the powder with lasers. The metal binds where it's melted and remains powder where it's not. Once the shape has cooled, another layer of powder is added and the part is built up layer by layer. For rocket engines, an Inconel copper superalloy powder is used because it can withstand very high temperatures. Selective laser sintering allows for multiple components to be printed in-house as one unified part in a matter of days. When a RUD occurs and the fault is found, engineers create a fix using 3D modeling software, integrating highly complex parts into new rocket engines for test firing a few days later. Using 3D printing also helps manufacturers reduce the weight of the complete rocket, as fewer nuts, bolts, and welds are required to produce their complex structure. 3D printing is especially useful in manufacturing an engine's complex regeneratively cooled nozzle, which routes cool fuel around the hot engine to simultaneously cool the engine walls and preheat the cold fuel before combustion. Virtually all new rocket companies and space startups are adopting 3D metal printing technology. It accelerates their development phase, helping them survive the crucial years before they manage to get anything into space. Of note are Rocket Lab, which uses its 3D printed engine to launch rockets from New Zealand, and Relativity Space, which is 3D printing its entire rocket. In the UK, there's Skyrora and Orbex. The latter aims to launch a rocket using a 3D printed engine as early as 2022. It remains to be seen whether an entire rocket, including its engine, can be 3D printed in one piece. But that's clearly the direction of travel for an industry in which lightweight, complex in-house manufacturing. Additionally, Relativity in February unveiled plans to build a bigger and reusable rocket called Terran R, designed to take on the Falcon 9 rocket that has become the workhorse of Elon Musk's SpaceX. Relativity already has the world's largest 3D printers, capable of manufacturing a single piece of metal up to 32 feet tall. About 95% of the parts for its Terran 1 rocket are 3D printed, a process which Ellis touts as making the rocket many times less complex compared to traditional rockets. Additionally, Relativity says its simpler process will eventually be capable of turning raw material into a rocket on the launch pad in under 60 days. While Relativity has invented our own 3D printers, that's not the most innovative thing, actually, Ellis said. I think the most innovative thing that Relativity is doing is that we're the world's first end product 3D printing company. We're not just building the printer and selling it, and we're not just designing the product and buying someone else's printers. We're actually integrating both of those together. I hope this video was interesting. Thanks for watching this video, and if you think this video was worth watching, then don't forget to hit the like button and share it.